Mm. So again, take a minute, go to your Canvas page, and then just keep your computer in the quiz tab section. So this time I think it starts at 8:35. So, but yeah, so just go do your duo code, log on to Triple E, and then just maybe just keep your computer on that quiz tab. So so basically when I end it, you could go straight to your quiz. Are you all good? Need more time? Yes, no. Are you all on the quiz tab? Okay, cool. Okay, let's get started. So your quiz is actually on FTC 1 and 2, right? It's 5.3. So I went over FTC 1 last time. So today we'll go over problems on FTC 2, and that should pretty much be it. So let's recall FTC 1, yeah? So, FTC 2. Integral AB f of x dx is f of x evaluated. So this notation just means f of b minus f of a. So f is any antiderivative of f. Yeah. So note that, how do I say it? It doesn't matter what c you choose, right? Because I guess the easier way would be just, let me show you an example, right? If it's from 0 to 1, right? What's an antiderivative of, say, x? So just give me one, your favorite one. I mean, most people would just take c to be 0, but so you could choose this, right? This is x squared over 2. And what you're going to see is that this is a half, right? Because 0 squared is 0. And you see, it doesn't change if I do the plus c, right? Because what you're going to get is 1 squared over 2 plus c minus 0 squared over 2 plus c. And what you're going to see is that, like, pretty much when you evaluate, the c sort of goes away. Yeah. So, might as well, unless you're a master, just might as well take c to be 0. Yeah. So it's independent of whichever thing you choose. So this thing is called a definite integral. I'll go over indefinite next time. It's just the general antiderivative. But for today, we will just go over how to do, questions on these. Okay. Let's start off easy and then we'll go hard. -2 to 3 x squared minus 3 dx. Okay, so what should I do? So I mean, this is, part of your quiz. So, you know, let's see if you all know how to do this. So what's the antiderivative of x squared minus 3? Take c to be 0. One third x cubed minus 3x. Yeah, good. And then you evaluate at -2 and 3. Yeah, so make sure, you don't, if this is your first time, you're evaluating at the top and then you're subtracting the bottom. Don't do like bottom minus top. Yeah. So it's 3 cubed minus 3 times 3 minus, and then you plug in -2, right? Plus 6. So this is what? 27, 9 minus 27 minus this is -8, so -8 over 3 plus 6. Yeah, whatever this is. -18 minus, what is that? 6 is 18 over 3, so 10 over 3. And this is 50. Oh, you're just adding. So -64 over 3. Yeah. Everyone good with this? So let me just say, there was a question on Canvas, right? Like, if if your function is like above, then the integral is the area under the curve, right? But like, if your function's below, the integral is going to be negative, right? Like, so uh is 3 times 3 not 27? Am I going crazy? I'm pretty sure it's 27, right? 3 times 3 times 3 times 3. Oh my god, I'm dumb. I'm stupid. Thank you. I don't know. I don't know why I thought it was 27. Okay, in this case, it's just, yeah, thank you for correcting me. It's 10. Yeah, I tend to make a lot of algebra errors, so please tell me if I do. So this thing, right, it's possible for integrals to be negative, yeah. So it's not really exactly area under the curve, it's absolute value of, like, you know, if you want the absolute value of the integral is the area under the curve, yeah. So it's possible it's integrals could be negative, right, if your function is below. Okay. Let's continue. Let me read. Not necessarily, right? I mean, I can ask this, right? In which case you would evaluate the, but you have the law, right? That integral a to b is negative integral b to a, right? So since you know this thing, we just solved it. It's negative 10 over 3. This thing's 10 over 3. Yeah. I mean, it's just this rule, right? B to A. Yeah. Yeah, this is A.
Quick question. So the top wouldn't have to be the larger value, would it?
No, it doesn't.
Okay. Thank you.
I mean, it's just when you interpret it, it's a bit more difficult, right? We normally say area from like the smaller one to the larger one. But what I'm saying is, if you're uncomfortable like with this, you could just swap it to this.
Oh, okay, okay, thanks.
You could swap it to this and then just put a negative sign if you're uncomfortable. Okay. Yeah, I'll try to review FTC1. Okay. So moving on, this was pretty easy. So in general, right, you have to know the antiderivative, right? If you to be like really fast to do these problems, you have to know your, so basically it's good to know derivative, right? Because if you know how to go forward, it's easier to go backward. I mean, it makes it easier going backwards, just a little, right? So here, this might not look familiar, but if I take out the 4, then you see that this starts to look familiar, right? What's the derivative of what gives 1/1 plus p squared? Good. Arctan of p. I'll leave this on the outside. So arctan of p evaluated at 0 and 1. Okay, so now comes the question, right? So the answer is this, right? But obviously we would not give it to you like this because we would want you to figure out what this is. So what is arctan of 1? Can anyone tell me? So again, it's math 2. You're gonna have to know math 2A trig. Yeah. So make sure you know this. So pi over 4. Does everyone know how I got pi over 4? Like, is that perfectly clear? Okay. So before I mean, for degree or radians, I mean, like your quizzes are like multiple choice, right? So we're either going to give you like degree or like radians. Okay. So I'm gonna just go over really quickly and then I'll tell you like what question to ask. Yeah. So if like a function takes 1 to 2, let's say 5 to like pick your favorite number, like pi, what does the inverse function do? What does it take 2? Can anyone tell me? Forget inverse trig function, right? You need to know what an inverse function is. So what does the inverse function do? If f takes 1 to 2, where does f inverse take 2? Yeah, it takes 2 back to 1, right? And then it takes pi back to 5. Yeah, so if f takes x to y, f inverse takes y to x. I mean, it makes sense, right? From the name inverse. So inverse trig is just, it's a trig function, and it's the inverse of that trig function. Yeah, it's just the inverse of tan. It's the inverse function of tan. So what it's saying is, so tan inverse of 1, the question, this question mark is tan of what gives 1? Yeah, you're going backwards. So you're asking tan of what angle gives 1? And you see that it's pi over 4. Yeah, so that's how you get pi over 4. So similarly here, tan of what angle gives 0? Yeah, 0. Yeah, tan of 0 is 0. Right? So so here, right? Because if tan takes pi over 4 to 1, then tan inverse takes 1 to pi over 4. Yeah? So yes, you do need to know the unit circle. So here's another thing, right? The inverse function is, when we write tan inverse, that's why if you go to, remember math 2A, you restrict it to some interval. Yeah? Because of course, right? Like sine and sine inverse, right? Like sine is like this, right? For example, let me just, yeah, it goes from like negative pi over 2 to pi over 2. But here, there's a reason you need to restrict it to some interval, right? Because if I ask you, if sine takes like 0 to 0, 2 pi to 0. I mean, sorry, not 2 pi, this is pi. Pi to 0, right? 2 pi to 0, 3 pi, right? So like sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0, so on and so forth, right? Then what? Then if I then where does sine inverse of 0 go? You see, it's ambiguous, right? Because it wouldn't be well defined, right? Because you can map to 0, you can map to pi, you can map to 2 pi. I mean, this wouldn't be a function, right? A function, you can't take one input to like a million different outputs, right? That's like that's not a function. So you have to restrict yourself to some interval, right? So if you restrict to like between negative pi and pi, then you could choose one. Yeah. And the book just makes a choice. Yeah. The book chooses negative for tan inverse. The book chooses negative pi over 2 to pi over 2. You could choose another interval, but that's what the book goes by. So is everyone clear on this? Yes? No? Trying to review math 2A in like 2 minutes. So your answer is like pi. Yeah. Everyone clear on this? Okay. So moving on, let's do one more since I'm gonna since you want review of FTC1, I'll skip this one and then just go straight to this one. So cosine squared theta, d theta. Yeah, so a priori we don't have rules for like you haven't really learned any techniques for solving these. Sorry, I need how about instead of I'll just do A and B, yeah, and then like I think that part's just algebra, so like we'll just focus on how to find the antiderivative for now. So for this, right, like you don't really know many rules for this. So what I suggest is if you see a denominator, right, split it up. Yeah. Especially if it's like, if I gave you something like this, right? If I give you an integral like this, your first idea would be to split it up into powers, right? And then each of them you know how to do, right? This thing's x, this thing's x cubed over 3. And this thing is 5 ln absolute value of x, right? So same thing here. If you go 1 over cosine squared, and then cosine squared divided by cosine squared is 1, right? So can anyone tell me what the antiderivative of 1 over cosine squared is? If you like, I can make it easier. This thing's secant squared. Yeah, because secant is 1 over cosine. So derivative of what gives secant squared? Yeah, 10. Right, so your answer is 10 theta plus theta, right? I mean, antiderivative of 1 is, I guess it looks weird to you because it's theta, but like if you do this, right, you would say this is x, right? Or if you like x plus c, yeah? So same thing here, but except instead of dx is d theta, so it's theta. And then you evaluate at a and b. Yeah, is everyone clear on this? I mean, I trust if I gave you what a and b is, you can do the algebra. Okay, so the last thing I think is for your web work. It's more for your web assign. It's integral of absolute values. So if I gave you something like this, right? How would you do this, right? Nobody told you what the antiderivative of an absolute value is. So my suggestion is step 1, you integrate. sorry, you get rid of, that's step 2. You get rid of the absolute value, right? And then step 2 is integrate. So make sure you understand this, yeah, because I'm pretty sure it's going to be on future, midterms and stuff. This seems pretty common. And I think it's on your website. So for this, right, I'm not trolling you. What's absolute value of -1? Yeah, so not a trick question. What is this? So yeah, it's 1, but another way to think of it is it will negate any negative number and make it positive. Yeah. And what's the absolute value of a positive number? Like absolute value of 1, for example. Again, not a trick question. It's 1. Yeah, it does nothing to it, right? If I absolute value a positive number, it does nothing. So your first step is to figure out when this is positive and when this is negative, right? And what you're going to see in this case is kind of, you could just do it from just looking at it, right? It's negative from 0 to a half. Agree? Because at a half, you are 0. 2x minus 1 is 0 at a half. And then so anything smaller, you're going to get negative, right? So what we're going to do is we're going to use that law, right? We could split this up 1/2 to 2, right? Of dx. So again, let me ask you now, from 0 to a half, 2x minus 1 is what? I just said it earlier. Is it positive or negative? If I just look at the inside, 2x minus 1. Is it positive or negative from on the interval 0 to a half? Negative. Okay, so what does absolute value do to negative things? You answered it for -1. It negates it, yeah? So that's sort of why I wrote the negative thing here. It negates it, right? So you can make it negative, and then so you get 1 minus 2x, right? Everyone agree? So now that's how you get rid of the absolute value. Yeah, you figure out where it's positive, negative. Okay, so same thing here. From 1/2 to 2, right? Is 2x minus 1 positive or negative? Okay, so what does absolute value do to positive things? Yeah, it does nothing, right? It does nothing to it. Good, and then I trust you can all do this, right? Without the absolute value, that this becomes easy, right? So this is x minus, so x squared over 2 times 2 is just x squared. Value at 0.5 plus, and then antiderivative, this is x squared minus x, right? Evaluated at 1/2 to 2. Is everyone clear on this? Can I trust you can all do this algebra?
Yeah, I was just wondering, why did you choose 1/2? Did you just set it equal to 0?
Yeah, I mean this I just looked at it sort of. I mean, it's kind of immediate, but yeah, you would set it equal to 0,
Okay.
and then you would say x is a half. So that's when it's 0, right? So if you think about it, whatever function, if it's 0, the only way, like when's the only way you can go, at least for continuous functions, you can go from positive to negative, right? If you started out positive, the only way you reach something negative is if you pass the x-axis. Agree?
Mm-hmm.
And
Okay.
that's exactly when you're 0. So so when x is a half, and then now you test it, right? Because it could go like this, right? It could go like at a half, and then it goes back up, right? For example. So you would test it. So at a half, and then you pick your favorite number before a half. Let's pick 0. Yeah, like 2 times 0 is -1 is -1. right? So it's negative before a half, and then you pick your favorite point after a half. So I don't know, 2 times 1. Yeah. That's 1. So it's positive. Yeah.
Okay.
Does that make sense?
Yeah. All right. Thank you.
Okay. Okay. Is everyone clear on this? So I think on your web assign, at least the one I saw, because a student came to me in tutoring center. So I think it's something like this, right? Yeah. So how would you split this? I'm not going to do the whole question for you, but ren is sign negative and ren is sign positive, right? And you sort of see it, you split it from like 0 to pi, right? Plus integral pi to 3 pi over 2, right? Because sine is like this. Yeah. Overdrew. Yeah. From 0 to pi is positive, and then from here to 3 pi over 2 is negative, right? And then same idea as the one we just did, right? It's from 0 to pi is positive, so this just becomes sine x, right? Absolute value does nothing, the positive things. And then here it becomes negative sine x. Is everyone clear on this? So this part's easy. This part is the hard part. Everyone clear? Okay, so you wanted me to review FTC 1. So FTC 1 just says if, so the FTC 1 says if g of x is integral a to x, a is some number, yeah, a is a number, f of t dt, then g prime of x is integral, sorry, not integral, g prime of x is f of x, yeah? So example, if g of x was integral 1 to x, t squared dt, yeah? Then g prime is you just plug in x to it, right? Clear? So the hard part comes if you had like x squared, t squared dt, right? So I went over this last time. I'm not gonna do it again, but what you do is you would plug in the x squared, right, to t, and then you multiply by the derivative of x squared, right? Everyone clear on this? So if the top wasn't just an x, right? Because again, to use a theorem, everything needs to be satisfied, right? This thing has to be an x. So if it's not, then I went over it last time, but what you do is you plug in and then multiply by derivative of what you plugged in, right? And then obviously the third case scenario is like, x squared, x cubed, t squared dt, right? In which case here from, if you went over like last time's discussion, we split it up, right? So I go x cubed to a number, pick your favorite number, as long as the number's defined here, yeah? So 0 is defined here, right? So if this thing was like 1 over t squared, right? Choose like 1, right? Because I mean, you can't plug in 0 to like 1 over t squared, right? Or else, because you'll be dividing by 0. But in this case, I mean, just pick 0, might as well. Dt plus integral 0 to x squared, t squared dt. Yeah, so this is g of x. Right, and then now, how would you do the first one? So right now, it's, I mean, you know how to do number and function now, right? But right now you have function and number. So how do you reverse the roles? What do you need to do? Yeah, flip. So flip makes it, you get a negative sign, right? Sorry, running out of room. So let me just erase this. So, and now you know what to do from here on, right? G prime of x is negative, plug in the x cubed, you get x to the 6 times derivative of x cubed is 3x squared plus plug in the x squared and then multiply by derivative of x squared, which is 2x. Okay, everyone clear on this? So like FTC2 page. Which one? Like the beginning or like just the which problem? Because we did a lot of FTC2 problems. Oh. Oh, sorry, there should be 0 to 1. Yeah, so for FTC2, just choose C to be 0. Yeah, don't like, don't make things harder for yourself. Okay, it's almost 8:35. So maybe if you haven't already, go to the Canvas page and then turn on your camera. And then maybe you have like 3 minutes to last minute study. So can I stop sharing? Is this good? I mean, there's nothing to memorize. Just if you see it, just do antiderivative and then evaluate. That's all it is.